Okay, I've gone back and forth on this several times. What I'm going to do, here's the thing. It's Monday night, I'm recording this. It'll probably be released tomorrow sometime. Only 5 people turned in the lab, and out of those 5, 1 person did it correctly. Did it perfectly. The rest, I couldn't really give credit. So what I wanted to do is give you an alternative. I want you to see the lab done right. I want you to see it before the final, because it will help you study for the final. So here's what I'm going to do. I'm going to release a video showing you how to do it, kind of like an in-class. You guys complete the lab, and I can give you what's fair. I'll give you 80%. You can get an 80. So if you turn in after the 27th, which is when I'm making this video, so 28 and forward, if you turn this in sort of in-class in quotes lab in, you can get an 80 as long as you do everything correctly. I'll still check to see if it runs. There's no excuse, really. If you can't follow along with this and get it to run, you were given the starter code. I'm going to show you how to do it. If you can't, I don't know what to tell you. Okay, so here's what we got. So again, the point of this lab was to really just kind of practice with passing arrays as arguments and returning them as values, and just kind of working with arrays in general. So the whole passing back and forth and return values, the first few functions. Actually, this is probably not the way I would have done to generate player names. What I would prefer to do is use a method to, get a random name back and then assign that to an array element. But you need to practice returning an array as a value. So that's why I made it this way. And then at the end, you have a bunch of statistics. Those are supposed to just give you 2 or 3 slightly different experiences with iterating over array and totaling values up and stuff. So it was just meant to give you more practice, with the more basic parts of array mechanics. There at the end, the statistics part. So let me show you what's going on here. First of all, I did another video on random. I told you it was static random object. You don't need to ever type new random anywhere in this code. It's already been done once and for all. All you need to do now is use that random object whenever you need a random thing. So you'll use this variable throughout the rest of your code. This is a class, and you guys just started learning about classes. It's just the main class. You don't ever instantiate an arrays lab object, but you do have a field up here that has an array object in it. That's why it's static. It's hard to explain. You have to review all the stuff about what static means. But every method in this whole code can see this right here and use it. Same thing with the input. Whenever you need to input something, just use input. It's been declared at this level. So you guys ever putting, random gets new random or whatever in your methods on here, you shouldn't be doing that. It's reinventing the wheel. You don't need to do it. Alright, so I'm leaving this screen. I'm talking about this. You can see, well, actually, you don't have to type this. It's already done for you. But I'll try to leave up enough code for you to follow along. Okay, what's the point of this random names array? This is a bucket of names. Whenever you need a random name, you stick your hand in the bucket, grab one, pull it out. You're never meant to iterate over all 50 of them. The labs that you're working with are between the sizes of 5 and 20. This exists only to be a source of data. It's hey, I need a random name. Give me one. That's the only reason this exists. I think people are confusing the whole point about why this exists. And I hope you see it more later. And I tried to give you a clue in the video I made, the last one I made, about how to do this. But I don't know. I kind of feel like some of you are not watching all the videos before you attempt the lab. But anyway, so when that's all stuff declared up at the field level of the array. Everything in the array can see this. All that stuff. Now here's where execution starts. So let me make this a little bigger so nobody says, "Oh, I couldn't read it because it wasn't big enough." Execution starts here. I'll tell you exactly what you need to do. Use this variable whenever you need to refer to the size of the array if you haven't created any arrays yet. Otherwise, use always the length stored by the array. So this is meant to be like whatever the user types in, 5, 6, 7, 8, 9, 10, 11, 12, up to 20, right? Whatever they type into user input, you get it into user input here, and then you make this equal to that one time, final, right? Once it's been assigned a value here, it doesn't change. So this will be the size of the array you're working with. So if somebody types a 5 in here, or 6 or 7, that num players will be 7. And what do? You create an array of players that's 7 big. That's what generate player names does. And we'll show how that works here in a second. So first you get that number from the user input. You make it num players, and then you call generate player names with, say, we'll make 7 the example. So 7. What does it do down here? First, using the random names array, probably should have put that first. That might have confused you, but here's the important part. Create an array of strings. Create an array of strings. How big does that need to be? It needs to be big enough for all the players. So 7, size 7, num players 7. What I do is I iterate over that array that I just created, the names array. This is where I get the names for my players. So this will go from 0 through 6. And what do I do? When it's named sub 0 right here, when I is equal to 0, I get a random name from the random names array. Right? I generate an integer with my random. Notice I didn't declare it again here. I didn't say random gets new random. It's already there. You just use it. I get the next integer in the range from 0 to the length of the random names array, which somebody told me was 50. I can't remember how many names were in there. But so 0 through 49. It'll get one of those numbers. Let's say it gets 13. So it picks the name that's at 13, the element 13 in the random names array, and assigns that name to name sub I, whatever name sub I is on. So this will go, again, in our example, we're doing 7 players, so it'll go from 0 to 1 to 2 to 3 to 4 to 5 to 6. Getting a random name each iteration of the loop from the random names array up here, right? Maybe you'll get this one the first time, then this one, then this one. So name sub 0 gets that. Name sub 1 gets this. Name sub 2 gets this, because you can allow repeats. I didn't say you had to, avoid duplicates. That would be a little more work. Name sub 0, name sub 1, name sub 2, name sub 3, name sub 4, name sub 5, name sub 6, and we went to 7, right? It should be 7 names. So it would be like, 7 names out of all these randomly is what this code right here does. You create an array of size 7. That's what size will be, because that's the argument you sent to. It was num players, right? Num player. We said num players was 7. So 7 comes in here. You create an array of size 7. You iterate over that array from 0 through 6, getting random names each time. Then you return those names. So where it says this is a dummy variable, even I've got it here. You should get rid of that now. I have it return new string 0 just so it will compile. That doesn't mean that's what you return. You shouldn't have new there at all. Where's your new? Where's your new? Your new's right here, new string size. That's when you create the array. You return the address of that array, which is stored inside of names, up here. And that address, that names array that you just created, will go in here. So players becomes names array. You hand off like a baton in a relay race. So now you have your array of 7 random players. in the players array. Then you want to get the scores for each of those players. So you send that array as an argument. So this input scores, if you look at it, it should take a string array as a parameter, which it does. I went ahead and called it players in here too. I could have called it P. I could have called it guys, people, whatever, but I called it players again. Keep in mind, this players is a different name, but it's the same array. It's the same array address that I'm sending. I send that. Why? Because what I want to do, first of all, create an array of integers that's the same size as the array of players. Players.length is the size of that array. Create an array of integers that's that size. Notice I don't use num_players or anything. First of all, num_players it's a local variable in main anyway. It wouldn't know what I was talking about. But once you have the length of an array, once you create an array, you should always use this at length. I want this array that I'm about to create of integers to be the same size as this array of names. Why? Because they're parallel arrays. Player sub 0 is going to be, his score is going to be in score sub 0. And you can see that here where I iterate over the new array I just created of integers, and I say, notice it goes for scores.length. It could go to players.length technically. It's better if you stay within the same array though, but they're both 7 in our example. Now again, it could be 13, 10, 5, 20. It could be the length, depending on what the person puts in at the very beginning of the program, but we're using 7. So don't get confused. Some of you guys got to be a little bit more flexible in your thinking. Programming is all about learning all the little bits and putting them together in different ways, like building blocks. You can't be literal when you're listening to my videos and stuff. You've got to know what's an example and what's not. I know somebody's thinking everything has to be 7 now. I know somebody is. If you're doing that, I mean, like, reconsider what you're doing. If you're doing IT, you might be okay, but not programming. I'm telling you. I don't want to discourage anybody, but anyway, you iterate over this scores array. When you're on index 0, I will be 0. When I 0, you're talking about player sub 0, which is the first person in your player's array, and you want to know what his score is. So you assign whatever's read in from the user. That's the input.nextLine. Notice I don't have to create the scanner. It's already created. I'm just using it. It's up at the class level, so I can use it. I get the next line, parse it as an integer, and then I assign it to score sub 0. So player sub 0 will get his score at score sub 0. Then you go to the next iteration of the loop, and it'll be at 1. Player sub 1, which it prints out and prompts you, says, hey, what is player sub 1's score? And you say, player sub score sub 1, which is his score, will be whatever I read from the input. You go through this array, 0, 1, 2, 3, 4, 5, 6, in our example, because it's 7 in our example. Fill up that array with scores, and then you return scores. Why? Because this returns an integer array. You created an array to store the scores, and then you return that array that you created, and it goes where? Right here. It's also called scores. In main, it's called scores. 2 different variables, same name. They're working with the same object, too, the same array object. But so now you have your 2 parallel arrays set, filled up with names and scores, and all you need to do now is print them out. So print scores. Just do another array that's the length of one or the other. It doesn't really matter because they're the same length. And you print out player %s's score is %d, because when this is 0 and this is 0, which it will be on the first iteration of the loop because they're both the same variable, I, right? They're parallel arrays. Player sub 0 has the score that's stored in score sub 0. Player sub 1 has the score that's stored in scores sub 1, and so on. So that's just how you print out the scores. Pretty straightforward. That's all that done. The rest of it is, once you've got, I said, print statistics. That's a method. That's just showing you can have methods that call other methods. You could also like comment this out while you're working with it until you're done. That's one handy way, the fact that that's just a jump off point for all the statistics. So you notice like print scores, get max score, get min score. These are all separate methods, but they're all called from, let me get to it, it's the last one, print statistics. So print statistics first calls get max score. And what you should do if you're doing this is maybe comment all these out. Uncomment the first one that you work on, and then work on that till it's done, and then uncomment something else out and work on it. So this is how max score, this is in your book. I shouldn't have to show you this. This is straight from the book. I should just leave this for y'all to finish, but I don't want y'all like, you need to be studying for your final and your exam too at the same time. So the way get max score, and again it's in your book, the way you ever like find the max or min is you start with the first thing being your max. And this is a little off, mine's a little wrong, because you can just start at 1 instead, because you already got 0. But it doesn't really matter if you repeat anything. But anyway, you take the first thing. What you do is you look at it one thing at a time in your array. So you start with like, what's the first thing? It's 7. Okay, no, 7. 7's going to confuse people. It's 53. Okay, 53 is the biggest score I've seen so far because it's the only score I've seen so far. Then what you do is you keep looking at scores as you go through your array. I should change this to 1 just to make it more clear. So you get score sub 0 here, and then you start at 1 and go up through 1, 2, 3, 4, 5, 6, and you see if anything's bigger than what you already got. And if it is, you swap it out. You say, okay, if the score I'm on right now is bigger than the max that I have stored, then I'm going to change my max to be the current score. And when this is all done, you should have the highest score saved in max. And this is also not a dummy value anymore. You return max. And so notice the direction. If the new thing that I'm looking at is greater than the old biggest, then it's the new biggest, right? Min, you just flip. I should make you do that one because it's so easy. You just flip the sign. Change the variable names. You don't even have to, really. You could also not make this a separate method. You could like give another argument about whether it's min. There's different ways you can do it, but this is like simple. I wanted you to get practice of doing it over and over again anyway, repetition. So I changed the variable name to make sense. That's the only reason. You could leave a max and it still would do the right thing as long as you flip this sign. That's the only difference. Algorithmically speaking, this is the only thing that's different. Is this you flip the sign. Notice if it's equal, it won't make any change. So there's different people handle that differently. Sometimes if you do make it equal, you make the new, like it depends on whether you want the first biggest thing to be the biggest thing or the last biggest thing. But it doesn't really matter here because you're only looking for the value, not where it's located. All right, so that's get min score, get max score. This one started at 1, 2. I don't know why I started at 0. I'm just out of habit, probably. It doesn't really matter. You just repeat a little bit of work. Make sure I still get the right answers. So we'll do 7, which is our example. Put 3, 4, 2, 5, 1, 6, 8. You see the biggest score is 8 and the smallest score is 1, which checks out. So for the rest of this, make this big enough for people to read. So there's get max score, there's get min score. You guys can pause. I'm not going to pause for you. I'll give you enough time to pause, maybe. So that's get max score, get min score, get mean score. Now mean, I don't know why people have so much trouble with this, but the mean is just going to be the sum of the scores, which is something I told you to memorize, divided by the length of the array. Let scores.length. Make your variable a double, and it automatically does floating point. So double sum equals 0.0. That's where it starts off. sum up all the values in the array, which you should have memorized, and then divide by the length of the array. That's what a mean is, right? So that's really easy. I'm going to go on. Standard deviation is just, you have to look at the formula and see how to implement it, but I'll show you what I've got here. Okay, same thing again. You get the sum, but you also need the mean in order to do the standard deviation. So what do? You just call your mean, which should be done first. Get the mean score of your scores, and then you go through and you square the difference between the mean. This is what this does, and add it all up together. Then you divide the sum by the length, kind of like what you do with the mean, and then you take the square root of that. And it's also not a dummy value. And that's it. That's the whole lab. So again, this is down here at the bottom. It could have been anywhere. Any of these methods could be anywhere. The order doesn't matter. But what matters is the order you call them in main. So you notice everything is called from main except when you get to print statistics. Print statistics then in turn says, okay, call this, then call this, then call this, then call this. That's it. So turn this in for, I think I said 80 points. I'll stick with that. So if you've seen this video, it's too late to get full credit. Let's put it that way. You can turn this in. I am going to do this. I don't want you guys stretching this out. So this video exists. I'll announce it in class. And this will be due before the exam. So I'm going to say Thursday night at 11:59. That's this coming Thursday, so the last day of April. So before April ends, this is due. So this didn't take as long as I thought it would. I mean, it's only 22 minutes for me to long-windedly. Let me let you one more time at the beginning. Here's the lab, right? That's a lot of this stuff you had downloaded. All this up to this point you should have. Here's the main method. Here's where you start. I think I even give you all this. Like everything's here. So all you need to know is generate players, player names. Generate player names. That's what that looks like. I don't know why I'm doing this for you. You guys can manage. Because I think you've seen all the code throughout the whole thing. There's input scores. Pause if you need to. Just print scores, really simple. You should probably get rid of all these to-dos once you finish this too, right? Get max score. If you didn't catch on the get min, I'm not going to show you again. It's back in time, but you should be able to do it without looking, really. Here's how you get the average or the mean. And here's how you get standard deviation. So I think the thing people are getting confused about up here at the beginning, at the very beginning, to generate and all that, is like you create the array down inside the method, then you return its address right here, right? String. You're returning the address. You're returning an array of strings, and I create that array of strings down here. So this is almost like I'm farming out the work. I could have said string players gets new string num players here, right? And then done all the work here. But this is part about trying to make your code modular. And again, I probably wouldn't do it exactly like this if I were doing this task normally. But part of the reason why it's designed this way is to give you practice, like sending right there. You're sending an array as an argument, and you have an array returned from a method as a return value. That's almost 25 minutes. I'm going to stop here and upload this tonight and then announce it tomorrow. So again, if you've seen this video, that means it's after the due time you could have turned it in for full credit, but you can return it. You can turn it in for 80 points by the end of April. If you turn it in after the end of April, like I said, I'd accept late work. There will be more penalty points. Maybe more than 10. Well, I don't know. We'll see. But to get 80 points, you should turn this in before the end of April.